Hello everyone, welcome to chemistry class chapter 5 language of chemistry. In today's session we are going to discuss about chemical equations, characteristic of a chemical equation, balancing chemical equation. What is a chemical reaction? So it is a chemical change in which one or more substances are destroyed and one or more new substances are created. Okay, so a change that takes place when elements or compounds react with each other under different conditions to form new products is known as a chemical reaction. Okay, so it is a chemical change. The very important thing is a change that takes place. Okay, okay. If you see here, before H2 gas and here O2 gas, after the reaction the H2O water liquid is formed. Okay, this is happen by chemical reaction. Okay, so a change that takes place when elements or compounds react with each other under different conditions to form new products is known as chemical reaction. Okay, okay, parts of a chemical reaction. So reactants, it gives products. So reactants means that substances that are destroyed by the chemical change. That means the bonds break. Okay, that is we called as reactants. Okay, substances that are destroyed by the chemical change. Products means substances created by the chemical change. Okay, for example H2 plus O2, it gives H2O. It's a new product. Okay, so substances created by the chemical change, that means new bonds formed. Okay, and then this arrow means is reads as yield. Okay, reactants gives how many yield? It gives a product. Okay, so the other symbols in chemical reaction. Okay, if they use S as a solid, L as a liquid, G as a gas. Okay, and then they are using AQ, aqua solution. Okay, that means what? The substance is dissolved in H2O. Okay, okay, and then this plus means it separates two or more reactants or products. Okay, this plus separates two or more reactants or products. For example H2 plus O2. Okay, so hydrogen one element, oxygen one element, so it separate two or more reactants or products. Okay, arrow, I already told that yield sign separates reactants from products. Okay, so an arrow is placed between the reactants and the products with the arrowhead pointing towards the product. Okay, okay, and then what is balancing chemical equations? So in this session we are going to discuss about balancing chemical equation. Okay, first, before that, what is a chemical equation? So chemical equation describes a chemical change. Okay, chemical equation describes a chemical change, and then I will give one example, parts of an equation. Now this is reactant and this is product. Okay, so Ag silver and H2S hydrogen sulfide react and give one product, silver sulfide. Okay, so this is an reactant and this is an product. Okay, this is a reaction symbol, an arrow. Okay, okay, now what is reactant and what is a product? What is meant by reactant? Reactant means the chemical or chemicals you start with before the reaction. Okay, the chemicals you start with before the reaction. And product Okay, the reactant written on left side of reaction. You said that before the reaction also, and that means what? Before means written on left side of equation, and product means the new chemicals formed by the reaction. This is right side of equation. This product you write right side of equation. Okay, now subscripts and coefficients. What is meant by subscripts and coefficients? Okay, first subscript. It shows how many atoms of an element or in a molecule. Okay, subscript shows how many atoms of an element or in a molecule. See, for example, H2O. Now see how many hydrogen here. How many hydrogen here? Two hydrogen. Here how many oxygen? Only one. Okay, so two atoms of hydrogen, one atom of oxygen is here. So that is the subscript. So subscript shows how many atoms of an element or in a molecule. Okay, it does not change. Okay, this subscript does not change. What is my coefficient? It shows how many molecules there are of a particular chemical. Okay, so it shows how many molecules there are of a particular chemical. Okay, this coefficient will be changed. For example, 3H2O, this 3 is called as coefficient. Okay, this 3 is called a coefficient. That means 3 molecule. Okay, 3 H2O, 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 3 types of molecule. Okay, okay, so it means there are 3 water molecules. H2O is a water, so 3H2O means 3 water molecule. Okay, now a chemical reaction. Chemical reaction. Hydrogen react with oxygen, it gives H2OC. 2 hydrogen react with this oxygen, gives 2H2O. Okay, see, 2H2 join with O2, it gives 2 hydrogen, 2 water molecule will be going. Okay, so this is a chemical equation. 2H2 plus O2 it gives 2H2O. 2H2 plus O2 gives 2H2O. Okay, now law of conservation of mass. What is the law of conservation of mass? In a chemical reaction, matter is neither created nor destroyed. In a chemical reaction, matter is neither created nor destroyed. In other words, we have to tell that the number and type of atoms going into a reaction must be the same as the number and type of atoms coming out. Okay, so the law of conservation of mass states that mass is neither created nor destroyed during a chemical reaction. Therefore, the number of atoms of elements on both sides of a chemical equation should be equal to show that matter is conserved. Okay, so in other words, we have to tell in a chemical reaction the total mass of the reactants is equal. The total mass of an equation is equal. Total mass of the reactants is equal to the total mass of the product. Okay, so only the reaction will be balanced. So the atoms only transfer and share electrons among themselves to form new compounds. Okay, if an equation obeys the law of conservation, it is balanced. Okay, so if any equation that will obey to this law of conservation, then only it is balanced. Okay, now word equation. How to write in word? If some equation, how to write in word? See here statements that indicate the reactants and products in a chemical reaction. For example, ion, chlorine. It gives ion 3 chloride. Okay, so ion is a solid, chlorine as a gas, ion chloride as a solid. So this you have read like this: solid ion, and chlorine gas react or combine to produce solid ion 3 chloride. Okay, this is the method to write these word equations. And then translating word equations to skeleton equations. A skeleton equation uses chemical formulas rather than words to identify the reactants and products of a chemical reaction. See the another word equation: ion, chlorine, it gives ion 3 chloride. I already told the skeleton equation means if you write the symbol ion, the symbol as a Fe, Latin word, ferrum, okay, and then chlorine, use the symbol Cl2, okay, ion 3 chloride, FeCl3, okay, FeCl3, so ion chloride, it will be combined, so ion react with chlorine, it gives ion chloride, okay, so a skeletal equation is not yet balanced by coefficient, okay. So one or more example. So see here 6Na plus Fe2O3, it gives 3Na2O plus 2Fes. Okay. Here the atoms are balanced. So the number preceding the chemical formula are coefficient. This 2, this 3, this 6, this we called as a coefficients. So they are used to balance the reaction only. So the numbers within the chemical formula are subscripts. So the number within the chemical formula, see this Fe2, this blue color, okay, Fe2, this 3 and this Na2, these are the numbers within the chemical formula as subscripts. So this subscripts does not change, only the coefficients only change. So you can read the above balanced reaction as 6 atoms of solid sodium plus 6 atoms of solid sodium plus 1 formula unit of solid ion 3 oxide yields 3 formula units of solid sodium oxide and 2 atoms of solid ion. Okay, okay, or you have to tell like this also, 6 moles of solid sodium plus 1 mole of solid iron oxide yields 3 moles of solid sodium oxide plus 2 moles of solid ion. Okay, so chemical reactions can never be read in terms of grams. Keep it in mind, students. These chemical reactions can never be read in terms of grams, only in terms of particles or groups of particles read in moles. Okay. Okay, see the unbalanced equation. So this is unbalanced equation. CH4 plus O2 gives CO2. This carbon combine this oxygen. So it gives carbon dioxide and water molecule H2O. So this is a reactant side and this is product side. Okay, so 1 carbon atom, 4 hydrogen atoms, here 2 oxygen atoms. Here the product side 1 carbon atom, here 2 hydrogen atoms. So carbon atom are same, but hydrogen is not same. Here 4 hydrogen, here 2 hydrogen, here 2 oxygen, here 3 oxygen. So it is unbalanced equation. Okay, now this is a balanced equation. See CH4 plus 2O2. Now I balanced it. 2O2 here, 1 carbon. See here 2 2s of 4 oxygen. 2 2s of 4 oxygen. Here also here 1 2 oxygen. Here also 2. So 2 plus 2 4. Here 4 hydrogen, here also 4 hydrogen, here 1 carbon, here 1 carbon. So this is a balanced equation. Okay, how we balance the reaction? So it have some rules of, okay, it have some rules. See the rules of the game. So first point, matter cannot be created or destroyed. The first point is matter cannot be created or destroyed. The second one, subscripts cannot be added, removed or changed. Okay, subscript does not change, cannot be added or cannot be removed, cannot be changed. And then you can only change coefficients. You can only change coefficients. Fourth point, coefficients can only go in front of chemical formulas, never in the middle of a formula. Okay, and fifth one, so if you see a few extra tips, try balancing big formulas first, save free elements for last. Okay, and then if the same polyatomic ion appears on both sides of the equation, it is usually okay to treat it as one unit. Okay, there is no one particular way to balance equations. Some equations are harder to balance than other and might require some creativity to solve. Okay, okay, now See how to balance the chemical equation. Okay, now I give one example. Okay, I will give the 5 example to you. Step 1, 5 steps. First, count the atoms on each side of the equation. So count here sulfur 8 sulfur, here oxygen 2 oxygen. Here you see only 1 sulfur, here 2 oxygen. Okay, so see here so sulfur here 1, here 8, so it is not balanced. Okay, see the step 2, coefficient, you have to balance, use the coefficients. Okay, so here you see, okay, see the coefficients. Now I add to sulfur here, sulfur 8. Okay, so I add 8 sulfur here. Okay, so I add the coefficient 8, so we get here sulfur 8. Okay, here only 1 sulfur, now I add here 8. That means if I add here 8 means here oxygen that changed to 8 2s are 16. Okay, it also happen. Okay, see 1 8s are 8. Now this sulfur balanced. Okay, now this sulfur are balanced. Now see oxygen 8 2s are 16. Now see here only 2 oxygen, here 16 oxygen. Now for balance this oxygen you have to add here 8. So now 8 2s are 16. Now this is balanced. So here 8, here also 8, here oxygen 16, here also 16. Okay, so this is step number 2. Okay, step number 3, only change the coefficients. Okay, only you have to change the coefficient, not the subscript. See here hydrogen 2, here oxygen 2, here hydrogen 2, here only oxygen. So you have to change right hand side. So if you add here 2 means 2 2s are 4. Now hydrogen will be 4, but oxygen 2. Now oxygen will be balanced, 1 2s are 2. Oxygen balance. Now you have to balance hydrogen, you have to add here 2. So the coefficient 2 means 2 2s are 4. Okay, so you have to change only the coefficients. Okay, now balanced. Now hydrogen and oxygen are balanced. This is step number 3. And then step number 4, dealing with polyatomic ions. If you see the calcium sulfate and sodium nitrate, so CaSO4 react with NaNO3. See this SO4 join with this Na2 and this NO3 join with this Ca. Okay, now you see the how many calcium here, only 1 calcium. Here sulfur SO4 only 1. Okay, here calcium 1, SO4 1. It is balanced. Here Na only 1, here NO3 1, here Na2, here NO3 2, 1 2s are 2. See in the subscript 1 2s are 2. So you have to balance, add here 2. So here 2 Na, here sodium will be balanced. Okay, NO3 also 2, NO3 also balanced. Okay, this is count polyatomic ions as 1 atom. Okay, okay. So see, count all the atoms. So another example, here carbon only 1 carbon, here hydrogen 4 hydrogen, here oxygen 2, here carbon 1, oxygen C 2, here 2, hydrogen 2, here oxygen 1, so oxygen 2 plus 1, totally 3, here 2 oxygen, here 1 oxygen, so 2 plus 1 3. So carbon balance, but hydrogen not balanced, oxygen not balanced. So you have to balance, add here 2, you get an 2 2s are 4 hydrogen, and oxygen also see, so 2 plus 2 4 oxygen. So you have to add here 2 2s are 4, add here 2. Okay, so this is an balancing an chemical equation. Okay, so now you have to know, now balance this equation. So balance this following equation by adjusting coefficients. See here, nitrogen, hydrogen and ammonia, NH3. So see the reactants. First you write the element name, N, element symbol, nitrogen, hydrogen. So nitrogen having 2, okay, and then hydrogen 2, and then having, and then product, this N having only one element. Here hydrogen 3. So you have to balance. First you balance this ammonia. If you add 2 means you have the 2 nitrogen, and hydrogen 3 2s are 6. Okay, wow. So first 2 nitrogen. So nitrogen will be balanced, and then hydrogen 3 2s are 6 hydrogen, and then so you have to balance this hydrogen. Here 6, here only 2. So you have to balance. You add here in table, 2 1s are 2, 2 2s are 4, 2 3s are 6. So you have to add here 3. Okay, so the coefficient will be 3. So 3 2s are 6. We get an 6. Okay, so balance. Okay, so see 2 nitrogen and 3 hydrogen. Okay, it will be balanced. See the another example, KCl3. So here only 1K chlorine oxygen. So only 1 potassium, 1 chlorine, 3 oxygen. Here 1 potassium, 1 chlorine, 2 oxygen. Okay. Okay. So if you see here, potassium 1, chlorine 1, oxygen 3. Here 1, here potassium will be balanced, but oxygen not balanced. First you balance these, add here 3 and add here 2. Okay, so you get 3 2s are 6 oxygen. First you see the left hand side, 2 potassium, that means here 2 chlorine. Okay, here 2 chlorine, 3 2s are 6 oxygen. Okay, see this side, 6 oxygen, 3 2s are 6. But you see here only 1 potassium, 1 chlorine. So you have to add here 2 means this reaction will be balanced. This equation will be balanced. So 2 potassium, 2 chlorine. Okay. Okay. So here 2 potassium, 2K, and this is chlorine, Cl, KCl, and this one oxygen. Okay, see the balance the following equation. Here C2H6 O2 CO2 plus H2O. These are the example. So now balance. Here see 2 2s are 4 carbon, here also 4 carbon, 7 2s are 14 oxygen, here 6 oxygen, and here 4 oxygen, 4 2s are 8 oxygen. So 8 plus 6, 14. Okay, so here the equation will be balanced. And see this Fe plus O2 gives Fe2O3. So here 4 Fe, here also 2 2s are 4, 3 2s are 6, 3 2s are 6 oxygen. So the balance, so the equation will be balanced. Okay, thank you students, thank you so much, thank you.